Alright guys, here we go. I'm going to try this out using something a little new here, so I apologize for the audio. It's not the greatest, but hopefully I can learn as we go here. So checking over our homework, page 141 to 142. The first couple problems here are the same as what we did in class. So for example, number 34, I'm just going to give you the answers here, and then I'm going to do number 36 so you can see how it goes. This is where we're given two numbers and we have to find the ratio. So for part A, we're looking for the ratio of A to B. So in this case, we're saying, oops, I guess I said I was going to give you the answers for this one. I guess I'll do this one, and then I'll just give you the answer for 36. So ratio of A to B, A is 10 and B is 30. That's going to reduce down to 1/3, or another way to say that is 1 to 3. For part B, we're looking for the ratio of B to A. So you guessed it, our numbers are just going to be flipped. We're looking at 30 to 10, or that's the same as 3 to 1, or 3 over 1 if we reduce it, which is 3. So the ratio of B to A is 3, or 3 times, we could say that. For part C, now we're looking for a percentage of A to B. So we're looking for 10 ratio to 30, which we already figured out before is 1/3. If we convert that to decimal, it's going to give us 0.3 repeating. We times that by 100 to get our percentage, and that gives us 33.3%. Okay, so for 36, just to allow you to check your answers here, even though they are in the back of the book, we have 1.125 for letter A. If you wanted that into a mixed number, 1/8 or 9/8, that way you could say, 9 to 8 is the ratio. If we're looking at part B, we have roughly 8/9, which is going to give us 0.89. If you converted that to decimal, 8/9 is what we'd be looking for there. And then C, going to a percent, we have that 1.125 from part A. We're timesing that by 100 to get our percent, and that gives us 112.5%. Alright, for number 46. 46 is dealing with some population, 46 is dealing with metric tons of beef that's produced. So we're looking for the first number as a percent of the second number. So our first number that's presented to us is 12 million out of 65.1 million. That's going to reduce to 0.184 as a decimal, and then if we times that by our 100 to get the percentage, we're going to end up with 18.4%. So just looking at a ratio of the first number, second number, and then converting it to a fraction based on our steps that we talked about in our notes, going from decimal to decimal to percentage. Sorry. Okay, 52. This is another one that was presented in our notes, talking about comparing two different ratios to see absolute change and relative change in terms of percent. So we're looking at two different cities here, Las Vegas and Dallas. I'm just going to put them right next to each other, that way we can compare them easier. Okay, so in terms of our population, We're trying to see percent increased. So we're going to take our new value, 565,000. We're going to subtract our original value, 478,000. Gives us a difference of 87,000. And then for Dallas, the same thing. We're going to take our new population, a little over 1 million, subtracting where we started, going to give us a difference of 56,000. So in terms of absolute change, our term for our population change for Vegas is going to be the bigger one here in terms of absolute change. Now in terms of relative change, if we're talking about Vegas and Dallas, we want to take our absolute change and divide it by our initial reference value. So we're going to take our 87,000 and we're going to divide it by the 478,000 that we had as the reference value. 0.182, times that by 100 to get our percentage, and that gives us 18.2% increase for Vegas. Okay, we do the same thing for Dallas. We're going to take our 56,000. We're going to divide it by our reference value, and that's going to give us a 0.047 times by 100 to get percent, and that gives us a 4.7% increase. Alright, so in terms of relative change, we're looking at Vegas again as having the bigger relative change. Same with the absolute change. Okay, so that was 52. I'm going to adjust my camera a little bit here. Figure out how to work this bad boy. Here we go. Alright, so 52. If our next problem was 54, see what that one talks about. 54 is about a percent change, find the absolute change and the percent change. So again, basically the same thing that we were just doing. We can look at our notes here. Congress delegation of California increased from 30 to 53. Alright, so we're just looking for percent change. Our new value is 53, and if we subtract our new value and then we divide by, or our initial value, sorry, reference value, and then we divide by our reference value, it's going to give us 23 over 30. We divide that out, it's going to give us, after rounding, it's going to give us a 0.767, and then again, following our procedure before, times 100 to get to percent, we should have a 76.7%, and that's increased because we've got a positive number. Okay, 56 is again the same thing. I'm not going to do all those out, but this one we should end up with a, oh my bad, we were supposed to look for relative change and absolute change. So our absolute change would be 23, and then our relative change, comparing the two, is a 76.7%. So for 56, our absolute change is a decrease of 431 million, and then with that, our relative change gives us a negative 45.75%. Okay. 58. is more of the same percent difference. So we should end up with a answer of 23.21. That's looking at life expectancy in Canada compared to Russia. So we should end up with a 23.2% difference there. Alright, and then these next few, 67 through 70, is where we are looking at prices and sales. Fill in the blanks in the following statements. This one really ties to the notes from the next section. So if you had issues with these, you can look at the notes that I am going to be attaching to the email, and it'll give you a little bit more detail as to how some of these work. So I just kind of used a little bit of common sense of, relation of figures, and I'll kind of walk you through what I did there. For these ones, if you had troubles, you can still look at the notes for the next section here that I'll be doing and attaching those in an email too. So 67 says, if we have a wholesale price of a TV that's 40% less than the retail price, the wholesale price is blank times the retail price. So if we're talking about the price that the store buys it, would be 40% less than what they sell it to you. So if we're talking about the wholesale price in comparison to the retail price, if we're saying that's 40% less, we would be saying that essentially the wholesale price is 0.6 times less than the retail price. And that's basically because we're saying that the wholesale is 40% less than, so this is 60% here. We're saying that if we took our wholesale price times 0.6, that would give us 60% of the retail, and that would be our wholesale price. So basically a store buys it for 60% of the cost that's on the price tag in the store. And we'll go into some more detail with that, like I said. Okay, 68 is a store is having a 50% off sale. Therefore, the original price of an item is blank times as much as the sale price. So if the sale price is half of what it used to be, then that means the original price would be 2 times. The original price is 2 times more than what the sale price is. So if something was originally $2, the 50% off would make the sale price $1. So therefore the original price is 2 times more than the sale price. Alright, number 69 says the retail cost of a TV is 30% more than its wholesale cost. Therefore the retail cost is blank times the wholesale cost. So this is again just kind of switching your terminology around. Now we're saying the retail cost is 30% more than its wholesale cost. So we're taking whatever our wholesale cost is, what the store buys it for, think of that as 100%. And if the retail cost is adding 30% more to that, we'd be saying basically we've got 100%, which is 1, and then we're going to add another 30%, which would be 0.3 if we're multiplying the cost. So for this one we would say 1.3 times more than the wholesale cost. And basically in terms of numbers there, what I just did, we have 100% wholesale cost and we're adding 30% of that. So basically that's just saying 100% plus the 30%, 1 plus 0.03 is 1.3. Okay, for number 70, there's 2 different ways we can get to this, and you'll see this in the next part of the notes. It says that a store is having a 40% off sale. The sale price for an item with a regular cost of $80 is, so we're looking for the sale price here. So one way that we could do this is we could say if our original cost is $80 and we have a 40% off, so we want to find 40% of the $80, that's going to be $32 off. So 80 minus the $32 gives us a sale price of $48. Now, we could do that, or we know that we're taking 40% off. So if we took our $80, we're getting rid of 40% of that, so we want to know essentially what is 60% of 80. So if we take our $80 and we times that by 0.6 for 60%, that still gives us our $48. And I'm not sure if you guys can see that with my logo there. I don't know if that shows up on your guys' screen or not. So 48 is our answer for number 70. Alright, and then 72, this one we will cover again in the next section. Just kind of getting you to look ahead a little bit. So we're looking for absolute change. We are decreasing here, so we should get a decrease of 6.9% for absolute change. If we looked at that in terms of relative change, we would have a negative 12.9% change from old to new. Alright, so there are your homework problems from last Thursday's class. That was the page 141, 142. I am going to be attaching your notes here directly and then also walking you through those answers so that you have a video to look if you have troubles filling any of those in.